Hi, I'm Sanjay Nagchaudhary from the IBM Integration Bus development team. In this video, I will introduce you to the new Callable Flow Async Invoke and Callable Flow Async Response nodes that have been provided in IBM Integration Bus version 10 Fixpack 8 and take you through a scenario which shows how they can be used. Callable message flows were provided in an earlier version 10 Fixpack. A message flow can directly invoke another message flow using the Callable Flow nodes. The message flows can be deployed to IIB on-premise or to IIB on cloud. When the message flows are deployed to different integration servers, a separate switch server is needed for routing data, and an agent file is needed to ensure the flows communicate securely. In this scenario, I have a flow running on a Windows machine which is using a loopback request node to retrieve entries from a collection in a MongoDB database. The flow has callable input and callable reply nodes, so that it can be invoked from another message flow. The bar file has 10 additional instances configured for this flow, so it can handle multiple requests in parallel. I have a separate flow using a Callable Flow Invoke node running on a Linux machine, which sends requests to the flow on Windows and processes responses. A bottleneck occurs as the server flow is not responding quickly enough before the next message arrives on the input queue on the client flow. Consequently, a backlog of messages is queued up waiting to be processed. We can eradicate this bottleneck by handling the requests and responses between the message flows asynchronously. Here is my flow running on my Windows machine. It receives requests using the callable input node and sends back the output tree in the callable reply node. The endpoint name is Windows_flow. The compute node sets the filter on what entry to retrieve from the MongoDB collection based on what is passed in the input message. For this demo, the compute node has a sleep of 3 seconds to simulate latency in the server flow. Here is my flow running on my Linux machine. The flow reads a message from an input queue and forwards it to the message flow running on my Windows machine using a Callable Flow Invoke node. The Callable Flow Invoke node specifies the target application and target endpoint name, which is Windows_flow. After the response is received from the server flow, it puts a message on an output queue. The next message on the input queue cannot be read until processing of a current message has completed. I will now run the necessary commands so that the flows can invoke each other. First, I run IIB create switch CFG. This generates configuration files that are needed by the switch. Next, I'll run IIB switch. This creates the switch server using the switch.json configuration file that was just generated. Now I need to run mqsi change properties on the integration server on the Windows machine so that the agentx.json is used for secure communication between the flows. The Windows integration node needs to be restarted for the changes to take effect. I need to copy the agentx.json from my Windows machine to my Linux machine so that I can run the command there too. Now that I've copied the agentx.json file, I can run the mqsi change properties command on my Linux machine. My flows are now able to communicate with each other using the switch server. The Linux integration node needs to be restarted for the changes to take effect. I can run mqsi report properties to check that the integration servers have connected to the switch server before I deploy. In my bar file, I've configured the Windows flow to have 10 additional instances. I will deploy the flow, which contains the callable input and callable reply nodes, to my Windows integration server. I will deploy the flow, which contains the callable flow invoke node, to my Linux integration server. After deploying, I can run mqsi report properties again to check that the message flows are registered with the switch server. I will put 3 messages onto my input queue. Each message contains an ID that is used by the flow on my Windows machine to retrieve a specific entry from the MongoDB collection. As you can see, there is a gap of 3 seconds before a response is received for each message. It takes 9 seconds in total to process the 3 messages. I will change the flow to use a pair of callable flow async invoke and callable flow async response nodes instead of a callable flow invoke node. I specify the name of the target application and the target endpoint name for the flow which is running on my Windows machine. Both nodes share a unique identifier so that they can be paired up. I can share data between the request flow and the response flow by storing data in the user context folder in the environment. In this example, I've stored the time before the request is sent to the flow running on Windows. You can optionally store a subtree in the user context if you want to. In the compute node, after the callable flow async response node, I can access the data that was stored in the user context. After making the changes, I will save the flow, rebuild the bar file, and deploy it to my Linux integration server. I will put 3 messages onto my input queue again. This time, I can see that the 3 messages were processed in parallel. It took a little over 3 seconds to process all the messages, whereas previously it took 9 seconds to process all 3 messages. I will now use the flow exerciser so I can show the contents of a message tree that were sent and received between the flows running on Linux and Windows. After I send in the messages again, I can see the user context contains the request time and it has been retrieved in the response flow. The local environment is returned from the Windows message flow in this demo, so I can see information from the loopback request node about what selection filter was used. The flow running on Windows has received the message body that was sent to it. It has XML NSC in the input tree, as the MQ input node in the Linux message flow was using XML NSC as the input message parsing domain. The Callable Flow Async Invoke and Callable Flow Async Response nodes have removed the bottleneck that existed before. The Callable Flow Async Invoke node can process the next message without waiting for the response of a previous message, as the response is handled by a Callable Flow Async Response node in a separate thread of execution.